Hello, Luke. Welcome to Lesson 87. Today we'll be talking about systems of equations. We'll be delving into those just a little bit more today. And then also we'll be talking about functions. And in particular, we'll be looking at a test by which we can discern if a graph is a function. So let's go ahead and get started. We'll begin with the systems of equations. And what they'll do is they'll give you a bunch of equations as they have done in the past. Only now you're going to have to do a little bit more work when you go to solve these systems of equations. And they'll be giving you variables with subscripts again. So this is kind of preparing you for story problems later on. So right now they have all the equations laid out for you. Later on you'll have to discern what the equations are based upon a story problem. So to begin with here, let's just read through the information given. And remember that what we're trying to do is we are trying to solve for t sub e and t sub w. All right? Those are the variables of interest in this case. All right, so let's look at the information that they give us. They give us r sub e times t sub e equals r sub w times t sub w. All right, pretty straightforward. And then they give you three other equations as well. Notice that these two are really nice equations because they've given us the actual values for r sub e and r sub w. There's really nothing that we need to do here. The work has already been done. All right, so the key equation here is, of course, this first equation, because that's the equation that has all four variables in it. Okay? Has all four variables. These other equations, those are what's required to solve this first equation. All right, so, and by the way, just as quickly to refresh your memory, recall that if we have an equation in four variables, such as this one, in order to solve an equation with this many variables, we need that many equations as variables. Okay? So in other words, we have four unknowns here. So we need four equations dealing with these four unknowns in order to solve for the four unknowns. If we only had three unknowns, we would need three equations. If we had two unknowns, we would need two equations. All right? Five unknowns, we need five equations, and so on and so forth. So kind of bear that in mind. If you know there are four things that we're looking for, well, then we're going to need four equations. And if we look, we have four. We have one, we have two, we have three, and we have four. Pen is going a little goofy here. Four. All right? So just as kind of a quick reminder. All right, so let's go ahead and start solving this. It's very straightforward. So let's start by, plugging in what we know. We know r sub e and r sub w, so let's plug that in. So we have r sub e, well, that is equal to 200. So this r sub e, we can sub in with 200. And then t sub e, they don't tell us what t sub e is, so we leave that the way it is, t sub e. And then equals r sub w. They tell us what r sub w is. R sub w is, it's 250. So we can plug that in for r sub w, 250. And then t sub w, they don't tell us what that is, so that again is an unknown. So we've gotten this equation in four variables down to an equation in two variables, which is great. But again, like I said earlier, in order to solve an equation with two unknowns, we need two equations. All right, so that's where this one comes into play. We need to look at the second equation. So if you think about it now, we're dealing with kind of this equation, and we're dealing with this equation, the two remaining ones. All right. Now, here, this also deals with the t variables, t sub e and t sub w. So that we're on the right track there. We're dealing with, again, just the remaining two variables. So we need to solve for one of these so that we can substitute it into this equation. All right, so this is kind of the additional step that we have to do today, and it's very simple. So pick a variable that you want to solve for. You can solve for t sub e or t sub w, either one. I will choose to go for t sub e. And if I solve for t sub e, I'm just going to subtract t sub w from both sides, and we end up with t sub e is equal to 9 minus t sub w. All right, so now once we have it in this form, we can take that and plug it into our equation over here. So maybe I'll go to a different color here. We're taking this t sub e, which is in fact equal to 9 minus t sub w, and we're going to plug that in to this t sub e right here. Okay, so we have 200 times t sub e, which is the same thing as 9 minus t sub w, just plugging that in, equals 250 t sub w. And now notice we have an equation in one variable. It's t sub w. That's the only variable we have. So we only need one equation to solve for that, and this is that one equation. So we can now work this out. So let's start by distributing through the 200. So 200 times 9 is going to be 1800 minus 200 t sub w is equal to 250 t sub w. All right, now if I add the t sub w to both sides, kind of get all of our t sub w's on one side, we're going to end up with, this will cross out, we end up with 1800 is equal to 250 plus 200 is 450 t sub w. All right, and then we can divide both sides by 450. Oops, 450. The zeros would cross out. We're going to end up with 180 divided by 45. And we could certainly just reduce that. Maybe I will actually divide that out. 180 divided by 45. That's actually going to give us 4 once you divide that out. So t sub w is equal to 4. So there, we have one piece of the puzzle that's been solved. So we've got this one taken care of. But we still have the t sub e. So what's the t sub e? Well, we can go back to, we could go back to either this equation or this equation. They both have t sub w in them. But in this one, we'd have to also plug in r sub w and r sub e again. So we'll just go to this equation, I think. And we'll take that t sub e plus t sub w. We know what t sub w is. It's 4. So t sub e plus 4 has to equal 9. Now this is a simple equation to solve. We subtract 4 from both sides, and t sub e is going to be 5, right? So there we have it. We have our t sub e, we have our t sub w. Those would be the solutions for this particular problem. So again, it's really not very different from what we've already done. Maybe the one exception is we have to take this equation over here and actually manipulate it. We have to solve it for either the t sub e or the t sub w before we can plug it into the main equation. All right? Excellent. So here we have another problem, and it's the same sort of setup. I've just written them out kind of, or vertically here instead of horizontally. It just maybe makes it a little bit less messy. So go ahead and try this one on your own. They gave you 4 equations with 4 unknowns, very similar to the last one. See if you can work this out on your own, and then we'll do it together. All right, so once again, we have 4 variables. We have 2 r variables, r sub 1 and r sub 2, and then we have 2 t variables, t sub 1, t sub 2. This would be the main equation. It's got all 4 of those variables in it. So that's kind of the equation that we're building into. And we can start plugging in. So we know that r sub 1 is equal to 30, so we can replace the r sub 1 with a 30. T sub 1, we don't know what it is, so we don't have anything for that. Plus r sub 2, well, r sub 2, they said it was 40. So that's 40 times t sub 2, which we don't know what that is. And then that's going to be equal to 360. Okay, now again, note that we have 2 unknowns, 2 different unknowns, so it's an equation in 2 variables. So in order to solve it, using a system of equations, we need another equation, right? We need another equation. So the other equation is going to be this one right here, right? And so how can we solve for this? And again, maybe I think in this one, I'll even write this right here. T sub 1 plus t sub 2 is equal to 10. Maybe we'll take a different approach on this one so that you can see how this is still working. Here, I'm going to write this explicitly as a system of equations. So all I've done is plugged these in to get my first equation and then taken the second equation and written it underneath. Now notice this is a system of equations in 2 variables. And you could solve this using elimination or substitution. All right. Now I know in the last problem we basically used substitution. We figured out what t sub 1 or t sub 2 is and plugged that into the first equation. So all we did was substitution in the last one. But maybe just to shake things up here a little bit, let's try using this with elimination. And the idea is just to recognize that these problems are dealing with a system of equations. And systems of equations are things that you've been working on for a very long time. So we're trying to just kind of develop that, get you used to that, and be able to use systems of equations with word problems, because that's what's coming down the pike here. Is you'll be given word problems, then you need to use systems of equations to solve them. All right, so here we have a system of equations in two variables, and we're going to use, again, like I said, let's use elimination this time. So let's multiply this bottom equation by, let's do a negative 30, okay? And if we do that, we're going to end up with negative 30 t sub 1 minus 30 t sub 2 is equal to 10 times a negative 30 is a negative 300. And then the first equation, we'll just rewrite that up above, 30 t sub 1 plus 40 t sub 2 is equal to 360. Okay, there's our system of equations. I've just multiplied the second equation by a negative 30, which is fine. Now I can combine these like I would any other time I'm solving a system of equations. And what does that do for us? Well, the negative 30 and the positive 30 here, they eliminate, and we're left with a positive 40, and a negative 30 is going to be a 10 t sub 2 is equal to 360 minus 300 is 60. And then we can divide this out. T sub 2 divided by 10, 60 divided by 10 is t sub 2 is equal to 6, right? So there you have it. T sub 2 is equal to 6. That's one of the variables they wanted us to solve for. So now let's find t sub 1. So to find t sub 1, we're going to go back to this original equation. We'll go back to this equation right here. And we'll plug in our t sub 2. So we have t sub 1 already plus t sub 2, which we know is 6, is equal to 10. And again, simple equation, subtract 6 from both sides, t sub 1 is equal to 4. So there, we now have our two variables. Now, you may have solved this differently. You may have used kind of the approach that I used on the last problem where we used substitution. But it's a good idea to start doing it this way, actually. Writing it up as a system of equations and then solving it like you would a system of equations. And that does include using substitution. That would be an acceptable method. But I do want you to recognize that these are systems of equations that we are solving. And again, a key component to that is recognizing that I have two variables here. That means I need two equations. So here's equation 1, here's equation 2. If there were three variables, I would need three equations. Okay? All right, very good. Now, moving on to something else. We're going to look at functions here, and it should be pretty straightforward. But it's a connection that we need to make between the functions that we've been doing and graphing. All right. So if we have a function, what did I say when we talked about functions? I mean, how do we know something is? Remember we talked about the differences between a function and a relation. Remember the differences between these two, right? A function just you have this input, right? This domain of inputs, and you plug something into, we're going to call it just like a black box here, and something happens in this black box, and then it spits out an output, right, in your range. So you take an input, something happens to it, you get an output, okay? Now remember when we talked about function, and this actually is the same thing that happens with a relation. You have an input, you grab something from the input, and something happens to it, and then it goes to the output, and you have something over here, right? And that's how these both are working. They both work the same way in that regard. However, do you recall what's the difference between a function and a relation? Remember that a function, for every item in the domain, there is only one item in the range that's going to match with it. Okay? So if you have this 1 over here and it matches to this 2, that's the only thing that it'll match with. The 1 won't match with another number in the range, right? So, and recall that, if we had a system of kind of relations between inputs and outputs, if I said, okay, if you give me a 1, it's going to go into this black box and it's going to spit out a 2. And if you give me a 3, it's going to go into this black box and it's going to spit out a 7. And if you give me a 1, let's say you plug in another 1 over here, well, then it goes into the black box and it spits out a 4. Remember I said this is not a function then, right? Because the 1 produces a 2, but the 1 also might produce a 4. Okay, the 1 produces a 2 and it produces a 4. Then it's not a function. It's not a function. Okay, it's a relation. It is a relation, but it is not a function. All right, in a function, every input can only have one output. Okay, now different inputs can share the same output. For example, if I have, a 1 that gets me a 3 and a 4 that gets me a 2, and then I also have a 5 that gets me a 3, and I have maybe even a 6 gets me a 3, and maybe a 7 gets me a 3. Okay, here's a bunch of my inputs, outputs. I could look at this and say, okay, this is a function. Even though the 1 gets me the 3, the 5 gets me the 3, the 6 gets me the 3, and the 7 gets me the 3, right? They all have as an output a 3. However, that's okay. That's all right. They can share the same output. But the key is that the 1 will only give me a 3. It's not going to give me anything else. The 4 is only going to give me the 2. The 5 is only going to give me a 3. And likewise, the 6 and the 7 are only going to give me 3s. All right? They won't give me more than one number. All right? So that is at the heart of the definition of what a function is. Okay, it's a relationship or a relation where every input has only one unique output. Okay? In a relation, it doesn't matter. An input can have multiple outputs. It doesn't matter. All right? So, with that all in mind, let's talk about some graphs. If I have, let's say I have the graph of a line that looks like this. Okay? And if I were to ask you, okay, does this graph depict a function? Does it depict a function? What would you say? Well, let's think about it for a second. A graph, a line, I should say, is made up of coordinates, right? And those coordinates can be located. So, for example, this point right here looks like it's, get there to the straight line. This point here looks like it's, at least we're going to call it this so that it makes sense to us. It looks like it's on, the 2, x equals 2, and y is equal to 2. So it looks like it's on the point 2, 2. All right? Well, that's a relation. You plug in a 2, and I get a 2. Right? I plug in an x, I plug in the 2. What do I get? I get the y, I get the 2. That's just a relation. If I plug in a 0 for the x, I get a 0 for the y. If I plug in a 4 for the x, I get, well, it's slightly less than that, but it's pretty much on the, what would that be? 1, 2, 3, 4. Y is equal to 4, roughly. Okay? If I plug in x is equal to a negative 2, where is it? It's going to be right here. Y is going to be equal to a negative 2 as well. All right? So all of these points have coordinates. And those coordinates can be thought of as relations. All right? So is there any point, any coordinate on this line where I, select an x, some x? Is there any point on that line where that x will give me kind of 2 y's? Will something give me 2 y's? In other words, is there more than one output for a given input? Because remember, that's what we're looking for here. That's why this one was wrong. I plugged in the 1 and it gave me a 2, or it gave me a 4. It could have given me either one. All right? 1 gives me 2, 1 gives me 4. Which one is it going to give me when I plug it in? I don't know. It's going to give me one of those two, a 2 or a 4. All right? So is there any place where the x that we select will produce 2 y's, or more y's for that matter? All right, so think about it. Just start selecting x's. If I take whatever this x is right here, If I go up, nope, it's only going to give me one y coordinate, right? If I select an x, right here, if I follow that down to the line, what does that give me for the y? It again only gives me one y coordinate. And I could go anywhere along this x-axis, pick any point, and I'm only going to get one y coordinate for that point. Okay, so yes, this graph would be the graph of a function. It is a function. All right, so you might ask, well, what would a graph of a non-function look like? Well, to answer that, let's draw one. Let's say I have a graph that looks like this. Okay, kind of a wild graph, right? But let's say that's what the graph looks like. So given this graph, is this a function? Is this a function? Well, you might have already guessed that I'm giving you one that's not a function, but let's look at y. So let's look at our x-axis. Pick a spot on the x-axis. Let's say I pick right here. What happens? Well, if I follow this x coordinate up, I intersect the line right here. So this right here is my y coordinate. So I have this for a y coordinate. However, if I follow this x coordinate down, I also have another intersection point right here. So there's another y coordinate right here. So you see, I have actually two y coordinates for this given x. All right, does that make sense? So even here, if I go here, follow this up, I have a y coordinate right here. Here's the x coordinate, but I also have a y coordinate down here. This is another y coordinate. So one x is producing two y values. Okay? And if it's producing two y values, it is not a function. This is a relation, but not a function. Okay? So with that being said, what's a quick and easy way of deciding if a graph is a function or not? Well, there's a nice trick that we often use in algebra, and that is called the vertical line test. All right? And the vertical line test means that if you look at the graph, anywhere, try to draw some lines straight up and down. If you can draw lines straight up and down through the graph, and it intersects the graph at least 2 points, then you know it's not a function. It's a relation. Now, the lines have to be straight up and down. Some of these aren't perfect, but we have to imagine straight up and down lines. And notice here that they definitely intersect that green graph at multiple spots as they go through the graph, right? Okay? You can see all these points where it's intersecting twice. Now, over on this side, this first graph, if I were to draw some vertical lines to do my vertical line test, I could draw as many lines and in as many places as I want. Pick any spot you want. It is only going to intersect my orange line in one location, right? It's never going to cross over this orange line more than once. And if that's the case, then you can say that graph is a function. All right? If you find a spot where you cross over twice, then it is not a function. Okay? It's as simple as that. So this is called the vertical line test. It's great. It only takes a split second to actually do, and it'll tell you whether or not a graph of a particular line is a function. All right, so let's try a couple more examples here. So let's say we have a line that looks something like this. Ooh, I don't like that. Try it again here. Right? Crazy line. Okay? And then maybe I've got a line over here that looks something like this. Okay? What do you think? Is this first graph a function? Does it represent a function? Stop and think about it for a second. Use your vertical line test in your head. What do you think? So if we use the vertical line test, we're just drawing lines. Whoa, that was terrible. We're just drawing straight lines through our graph, and we're just trying to find out whether or not these lines will intersect more than once across our graph, right? So, if I just continue to draw these lines, can I find a spot where it's intersecting more than once? And for this one, the answer appears to be no. It doesn't look like there is a spot where we can draw a line that's going to intersect with our green line more than once. They're all intersecting at just one point. Maybe the only spot that might be a little bit in question would maybe be this spot right in here. If this was the green line, if that was straight up and down at any point, then we could say that this red line is kind of crossing over more than one piece of that green line. But it does look like as it goes up, it also continues to move to the right across the page here. So there is an arc there. So I'm assuming that one is not a straight line. All right. So again, you pick your point on this graph, and you're not going to be able to cross over this green line more than once. So this would be a function. Yes, it is a function. Okay. How about this next one? What do you think? Well, so on this one, can you cross over more than one spot on the line with your vertical line test? Let's try here. Nope, that's only once. Let's try over here. Nope, that's only once. How about right in here? Nope, only once. However, what about right here? If I draw a vertical line right there, how many times did I cross over? It looks like I crossed over 3 times, right? I crossed over right here, I crossed over right here, and I crossed over right here. So that is all we need. All we need is one line to fail the vertical line test. And then we say, nope, not a function. This is a relation only. Okay? Not a function. Not a function. All right? Very good. So it's about as easy as that. So they'll probably give you some graphs and ask you whether or not they represent functions, and just start mentally even just drawing those straight lines up and down and just see if there's any place that you can cross over the line more than once. If there is, well, then it's not a function, it's just a relation. And if it does cross over only once in every location, then you can say it's not only a relation, it's a function. All right? Very good. All right, well, we will stop here today, and we'll pick up on more of this in future lessons.